Hello, my name is Badr Senoga, and I'm here to present a systematic review of human-computer interaction and explainable artificial intelligence in healthcare with artificial intelligence techniques. Those are the authors. There are 4 of them that came up with this paper. And so to understand, we need to first know what is human-computer interaction, that is HCI. This is mainly used for making technological interaction easy for the user. You may come up with a product, or let's say a smartphone, but if it is not easy for the user, it may not be a very good thing. So you have to also think about how easy it will be for the user. Then for another point that you need to understand is artificial intelligence, whereby here we mainly focus making the interaction intelligent. And then about explainable artificial intelligence, XAI, this is about ensuring that you explain the interaction to the end user in order to to create trustworthy environment whereby they can feel safe to use your product or your model or whatever product you have. So they need to feel safe. They need to feel that to give you their trust to use that particular solution or model. So having understood those terms, there are research questions here, and one of them is what are the problems in HCI, that is human-computer interactions? What is the significance of machine learning characteristics? What are the various explainability techniques? What are the problems and challenges in XAI? Then what are the challenges of XAI in healthcare and how to overcome it? Then we shall also look at what are the research gaps that are existing in explainability artificial intelligence in healthcare. And then what is the future of XAI in healthcare? So those are the research questions that we shall be seeing today. So what are the problems in human-computer interactions? So you realize that this is broken down into two other fields, that is usability as well as human-centered design, HCD. So usability is basically about the way the interface is, and whether it is it the deficiency of the interface. Is it easier to use in terms of the interface? Imagine an application whereby it has an interface or user interface which is not good, not easy to use. You're trying to type something, then another pop-up comes in, or a button tries to go at the top of the edit field that you are using to type your information. So if maybe say a developer developed or placed those UIs badly, the button, the edit field where you click the send button, so if you don't design it well in terms of the interface, it is a very bad, it's a very huge problem. That is the problem of usability. And then the other problem is these other problems, the HCD, the human-centered design problems that may be encountered include requirements that are not clear. Then there is also the design solution is not correct, and then the context of use is not clear. So realize that to solve these problems, it will be better to first understand the requirements of the client and involve that client to be part of the process. In that way, we would avoid these other problems, like we've seen, the requirements that are not clear. And of course, if they are not clear, there are higher chances that even the design solution is not going to be correct. So these are some of the problems with that we have when it comes to human-computer interaction. So in brief, you have usability. With human-computer interaction, we have usability, which has it has the option of effectiveness, whereby is this solution or the model that you're having or whatever system, can it complete a task? What is its ratio of success to failure? That is what we call by efficiency. That is what we call by effectiveness, sorry. Then efficiency is taking your the task, the time that this particular task takes. What about the time to learn? How long does it take for that model to learn? Then about another point for usability is satisfaction, and that involves user reviews, completion rate. If a user gives you a good review or a positive feedback whereby they are saying it is a good product, then you'll know that, okay, now I believe I was able to handle that part of satisfaction of the client. Then another part for human-computer interaction is the human-centered design, and this involves the option of analysis, whereby you can identify stakeholders, and then that will be, so for you to get those requirements, you need to identify stakeholders so that they are part of the process. And then you also need requirements, and of course requirements involve functional and non-functional requirements. And of course it is always better to have it when it is domain specific, not a general requirement. It has to be specific to the needs of the client or the customer or the user of that system or the model, the way you've designed or you want to design it and develop it at the end of the day. Then another component for human-centered design is design, whereby of course the interfaces have to be good. They shouldn't be boring, they shouldn't be frustrating, they shouldn't be affecting the experience of the user. You should think about the users at the back of your mind as you're developing or as you're trying to design a solution. The other part about human-centered design is evaluation, whereby you design solutions and then you evaluate. You find out, you test and check the results to see if they give out the best that the customer would want to get, or the user, for that particular solution. Now, what is the significance of machine learning characteristics? Realize that we have one of the characteristics is the fairness of the machine learning model, and of course this will ensure individuals will not be treated based on their race, their gender, their disabilities. So there is that fairness of the machine learning model. Then there is also transparency of the machine learning model, and this involves provides the user, it provides end users with information on how the model will be able to work. It gives you that information, so you as a user, you understand it is transparent, you know how it will work. And then the other factor in explainability of machine learning that is associated with providing the user with information on why the model is working this way. Why? You've put in something, or let's say you've put something, let's say an input or a word or a figure, or you've made a call on the phone. There is an output that you expect, but why is it happening? Can you be able to explain that to the user, or how it happens, what is involved in that process as you do the input and then you get the output? Why is it happening? Can you share that information? Then the other part is the trustworthy model. A trustworthy model provides safety to the user, and which makes use of the system with no concern. So you trust the system, you feel you're safe to use it. And of course privacy, which will not lead to unauthorized use of services. So we need to have privacy, so that I believe the person who is accessing this particular resource is the person who is supposed to access it, not people who are not authorized to access the resources or the service. So in brief, that is machine learning and its characteristics: privacy, transparent, autonomous, fairness, explainable. It has to be trustworthy and accountable, in brief. And of course, the point is at the top is privacy. It has to be having privacy. Now, for the what are the various explainability techniques? XAI, as we looked at it, is a combination of field of artificial intelligence and human-computer interaction. And so basically, explainability, artificial intelligence, it combines the artificial intelligence part of it alone, and then it also gets the human-computer interaction. Then it puts it together to achieve what we call XAI. So there are 11 techniques of explainability, and these include the following. We have text-based explainability, and this one you can use it to bring explainability model for generating text explanations of the result. So if you have, say, a result that is text-based and you want to explain, you can use this technique. So then you also have the other option, which is the local explainability, and then the local explanation, the local explanation, this one will help us to express the individual decision of the classifier. And then the global explanation, this one will help us. We use it as a whole for explaining the entire functions of the algorithm. Then the visual explanation, this one helps us with the visual behavior and the explanation of the model. You get to know the visuals instead of just text or words or audio. Then we also have another technique, and that is the one concerned with data extraction and better understanding of the model itself. So there is another one that is explanation by simplification, and this one for it in whole, you here with this explanation by simplification, a whole new system is rebuilt based on the trained model to be explained. So if there is a model that is there's a trained model and you want to explain it, then you can come up with a whole new system and you build it, but then you are basing on the other trained model. Then you try to compare and find the best fit. Then there is the feature relevance, whereby another it helps us understand the internal functions of the system for defining how it affects the decision. Okay, so there is another one, which is the provenance-based. Provenance-based explainability technique is used for illustrating explainability, and it is said to be one of the effective usability techniques. And then there's also the declarative induction, whereby it sets rules as well as tree and programs that are said to be human-readable representations. And of course, there is also the model for surrogate model technology. This one, as you hear the word surrogate, it is about you using that particular option. You can use other models as a proxy for explainability. Surrogate, the way you hear the word surrogate, usually you get it from you hear someone getting a baby for another person. So here you go ahead and you use the same technique. You use other models as the proxy for explainability. So you be like, okay, this particular model does this and this, and you can use it to explain it in relation to this other model that you're having. Then there's the last explainability technique, which is rule-based method, and it is good for learning the classification of the data. So those are the 11 explainability techniques. What are the problems and challenges in XAI and how to overcome it? So that is another good question. So realize we have major challenges such as security, performance, vocabulary, evaluation of explanation, and generalization of XAI. So for the challenge of vocabulary, the expert of the audience should be involved in the XAI model to determine what explanation they expect from that particular model. So you need to involve the audience, the people who are going to be using this particular model. Then there's evaluation of explanation. That is the second last option, evaluation of explanation. This can be explained by ad hoc experiences, ad hoc experiments, or the KPI method, and it helps us with where the proxy measures can be used, such as the number of rows, nodes, and input variables to be considered in an explanation, as well as an explainable model for evaluators. So it's about evaluating and being able to it being used by evaluators. Then there's another challenge, that is the challenge of performance, whereby we can use XAI performance by creating hybrid AI, combining different approaches, use of machine learning algorithm to work from existing expert built symbolic representations of physical models to leverage existing knowledge. So you can use the existing models already available. They are built by experts, and then from there you're able to go ahead and pick a few knowledge here and there, and then you're able to come up with your model representing the whole by leveraging the existing knowledge from that other already built model by the experts. So there is another option, another challenge, which is security. And then, of course, this is a very important thing that we need to have. So for the security purposes of XAI, perturbation have been given importance as input data to the learning model. To the learning models, the bias and the fairness are the key enablers for the security of AI models. So here with security, we need to go ahead and find out in case there is a XAI perturbation, and it has been given to the as the input data to the learning model. So what will happen to the bias? What about the fairness? So they will be the key enablers for the security of that particular AI model. Then the other so this is the explainable artificial intelligence in brief, as a diagram. You realize that before you from the human part of it, the human simply okay, so when you come here from the world, let's start from the bottom. When you go ahead and capture you go ahead and capture the information, then you get the data, and then you train this particular model. Then when you train this model, then you will have to, it will be in form of let's say it's in form of a black box model. With this, the black box model is like a system which we can only observe the input, and then we can also observe the output, but not the internal working. So it will be able to interrupt, then interpret for us. Then after that, we want to have an XAI here, the green one, the second top, which will enhance the interpretation. Because remember, with the black box model, for it doesn't give us what is in the mid, what is inside. It simply gives us it can only observe the input and then the output, but does not give us the internal working of that particular model. So we will need to get the XAI features to enhance so that the human being is able to understand what that particular model is doing or what it is all about, or the services it provides, or the solution. So what are the challenges of XAI in healthcare and how to overcome it? So some of the challenges is the system evaluation, organizational, legal, social relational, then communicational issues.